Welcome friends, in this session we will learn how to draw the graph of boost converter in a very simple way. After watching this video friends, you will able to draw the graph of this boost converter in just 1 to 2 minutes. Okay, so keep watching this video till end. You will learn some concept. Okay, so here this is a boost converter. Friends, the circuit is in a steady state. This is a small IC and this small IL. The small values represents instantaneous value of currents, and this V naught and capital letter friends V naught and I naught will represent our average values. Okay, so friends, again here the inductance L is sufficiently large, so during on period the switch will be on and the inductor will charge through this source VDC. Okay, so VL is equals to VDC I have written here. Okay, and in off period friends, when switch is open, so the inductor the voltage across inductor will be VDC minus V naught. So this is I have written. Okay, during off period. Okay friends, and here friends, see when the inductor is charging, the inductor L is sufficiently high, so this will be a linear slope. Okay, this will be a slope, this will be a linear line. Okay, because the inductor is high, not any other curve. Okay, so here the inductor will charge, and from here this is VDC minus V naught, the inductor will discharge through the load during off period. Okay, so in to draw the waveforms of capacitor current, diode current and capacitor voltage, we will first draw the inductor current graph. Okay, inductor current graph we will draw first, and from the inductor current graph we will draw other graphs. Okay, so the graph of inductor current is very important in this boost converter, not only in boost converter friends, in all other converters also. Okay, so friends, this the graph of inductor will be like this. Okay, when the switch is off, this inductor current will also be our ID. Okay, and this ID current, this diode current is splitting into two currents, IC and I naught. Okay, so our ID is equals to IC plus I naught also. Okay, so friends, here see this. So friends, here we will write one very simple KVL equation. The voltage across inductor L is L di by dt. So here the change in current is I max minus I minimum. Okay, this is I max and this is I minimum. So I max minus I minimum is our delta IL. Okay, the change in current. So L delta IL means L di by dt, and dt is the time period from which the current is changing. So here it is 0 and here it is dt. So on time here L delta IL by dt is equal to VDC in on time we have written. So here from this delta IL you can get VDC dt upon L. Okay friends, so this is one simple KVL equation we must remember. No other equation friends you need to remember. Every equation you can derive from this graph only. Okay, so here see this off period from dt to t, this IL current is I diode. Okay, and I diode is equals to IC plus I naught. What I have ID is equals to IC plus I naught I have written here. So we will draw ID graph from this IL. Okay, we will remove this portion, so ID is equals to this curve. Okay, like that. Okay friends, and so friends, the average current of this inductor is IL I have drawn. Okay, and this portion from here to here it is delta IL by 2, and from here to here it is also delta IL by 2. Okay, so this complete portion is delta IL. So half portion is delta IL by 2, half is delta IL by 2. Okay friends, so here we get IL average. Okay friends, so friends, what about this average of ID? ID is like this curve. So average here friends, this portion is not there, this portion is 0 here. Okay, so I naught will be definitely less than IL. Okay, IL average, I naught average will be definitely less than IL. Okay friends, so this will cross from here like that something. Okay, from there, from some below point it is crossing, because this DC component is adding and the average of this triangular pulse is also adding, so IL will pass like that. Okay, but here in ID our curve is not from 0 to dt, so this I naught will somewhat will be less here. Okay, and it will cross like this I naught. Okay friends, and friends, we know that ID is equals to IC plus I naught. Okay, so average of ID we will get average of IC plus I naught, And we know that friends, for the stable operation of this circuit, the average current across the capacitor should be 0 in the time period t. So average IC will be 0. So our average diode current is our average output current. Okay friends, our average diode current is our average output current. Okay, so from this ID, if I subtract this I naught, we will get IC. IC is equals to ID minus I naught only. Okay, so I naught we will subtract, so we will subtract this current I naught, this I naught from ID, so we will get like this IC. Okay, minus I naught, because here 0 minus I naught minus I naught, and this will, the curve will somehow come down. Okay, so like that we will get. Okay friends, so IC will come like this, and we know that friend, the area of this portion from 0 to on period and area of this off period should be equal for IC, average IC to be 0. So this IC, this area and this area is equals to A. Okay friends, and friends, we will know that C dV by dt is equals to IC. So dVc by dt slope is negative, so this slope will come down here, so voltage Vc slope will come down, so some ripple like that we will get here, because this is negative, dVc by dt is negative minus I naught. Okay friends, from dt here, and this is positive IC, so we will get positive slope. dVc by dt is positive, so we will get positive. Okay friends, like that we are getting, like that we are getting here, and again up, again down. Okay friends, so what is, so friends, this is nothing but our ripple voltage delta V. Okay, and the line passing through this will be our output voltage V naught. Okay friends, this line will pass through some here, so we will get our output voltage, and this is our ripple in the voltage. Okay friends, how you will get this ripple? From here IC, from here this, from this I naught dt is equals to C, we will get charge from this IC curve. Okay, I naught charge is what? Current into time, so I naught into dt is equals to Q. From here you will get delta Q, sorry, you will get here delta Q. I naught into dt is equals to delta Q, and delta V is equals to delta Q by C. So delta Q we will get I naught dt, and dividing by capacitance we will get ripple voltage. Okay friends, so if C is large friend, this delta V will, this ripple will be small. Okay, and I naught into D into T, so this D is, if the duty ratio of this boost converter is less, again delta V will be less. Similarly, output current if less, this delta ripple in the voltage will be less. Okay friends, if frequency is high, then ripple will be less. So to reduce ripple, these are the things. Okay friends, so we will get Vc like that. Okay friends, so so what about inductor voltage friends? Inductor voltage is very easy friends, this is on period, this is VDC. Okay, so this is VDC. From here this inductor voltage only I have drawn this inductor current. Okay friends, so this is VL VDC, and in the off period this will be down. Okay friends, in off period this will be down. So friends, this is our inductor voltage. So friends, here you must have getting one doubt. See friends, this Vc is only V naught, this Vc is only V naught, and V naught divided by RL is equals to I naught. So if I am getting ripple in this Vc, so I will also get this ripple in this I naught. So how I am making this as a straight line, even in output voltage, even when the voltage is average, how I am making this flat I naught. So friends, here this see this ripple current delta IL is always greater than delta V. In the converter, the ripple in the current will be always greater than the ripple in this output voltage. Okay friends, the ripple current is always greater than the ripple voltage. Something about is 20%, that ripple voltage is 20% of this delta IL. Okay friends, so here we are doing one approximation which is called a small ripple approximation. So that's why I am making these currents, that's why I am making this I naught here, I naught as a flat, because the ripple in I naught will be less as compared to the ripple in IL. Okay friends, and here ID I have drawn from IL only. Okay, so the ripple in I naught is always less than the ripple in this id. Okay friends, so I am making this flat I naught even when these values are in average values. Okay friends, so remember this point. This can be asked in an objective. The small ripple approximation we are applying during the analysis of this boost converter. Okay friends, you must remember that delta IL is always greater than this delta V. The ripple current, the ripple in the current is always greater than the ripple in the voltage. You must remember this point. Okay, so friends, and this is continuous conduction mode analysis. You can do the same for discontinuous conduction mode. Okay friends, that in discontinuous conduction mode the current IL will start from 0 and it will end at beta t. Okay friends, and from that IL you can draw ID, you can draw IC and VC, like that only you can draw. Okay, very easy friends. You have to analyze only IL. Okay, we have to draw only IL curve, and after that every curve will be drawn easily. Okay friends, even in discontinuous conduction mode you can draw like that only. Okay, that is also easy, no problem in that also. So friends, and in exam friends, the question will be framed from this only this graphs only, and from the values will be given here, and you can draw the graph within 1 to 2 minutes. If you practice 2 times, you will able to draw this in 1 to 2 minutes. So hope friends this analysis will be helpful to you. Thank you friends.